So volume of a pyramid is 1/3, here we go, 1/3 capital letter B times H. So that's going to be, oh, that blank is 1/3 the volume of a prism. So we are 1/3 times the area of the base times the height. Okay, volume of a cone is also 1/3 capital B times H. The volume of a cone is 1/3 the volume of a cylinder. Are we ready? All right, let's do some problems. All right, the slant height of a regular square pyramid is 25. So what you need to remember is vocabulary. The slant height, remember, is an altitude of one of the faces. So that's 25. The perimeter of the base is 56. So next thing we need to know, because it's a regular square pyramid, what kind of shape is the base? A square. So if the perimeter is 56, each side has to be 14. You got it. Find the volume of the pyramid. Well, to find the volume of a pyramid, we're going to use the formula volume equals 1/3 that capital letter B times H. So this is 1/3 times the area of the base times the height of the whole pyramid. Okay, so do we all agree the base is a square? So to find the area of the base, we're going to do 14 squared, 14 times 14. And now we need the height of the whole pyramid. Well, the height of the whole pyramid is the altitude right here, which we do not have. We need to figure it out. Remember, the altitude connects to the center of the base. So from the center to the edge is half the distance. If the total distance is 14, from the center to the edge has to be 7. This is a triple. 7 something 25. 24. So the height of the whole pyramid is 24. So we are 1/3 times 196 times 24. 3 does not go into 196, but 3 does go into 24. So I'm going to cross cancel 3 and 24 and get 8. Anybody multiplying 196 times 8? Say it one more time, Holly. $1,568? Yeah. Okay. 1,568 units cubed. Okay, we ready for the next one? Or are we still copying? Okay, next one. Find the volume of a cone with a base radius of 6 and a slant height of 10. So I'm going to draw this. Here's our cone. Oops. Our base radius is 6 and our slant height is 10. So volume of the cone is going to be 1/3 capital letter B times H. which is 1/3, and then area of the base times the height of the whole cone. What shape is the base? A circle. How do we find the area of the circle? What's the formula? Pi r squared times the height of the whole cone. Now I don't have the height of the cone. The height is made by what? The altitude, exactly. This is a triple times 2. You got it. So we are 1/3 times pi 6 squared times 8. I'm going to bring it up top over here. We are going on to 1/3 times 36 pi times 8. 3 goes into 36 12 times. 12 times 8 is going to give us 96 pi units cubed. On the quiz, you do not need to write the units. So you don't need to do units cubed if you don't want. All right, that's the end of 12.5. All right, 12.6, volume of a sphere is going to be 4/3 pi r cubed. And I also want you to write down the volume of the hemisphere. Volume of a hemisphere is going to be 2/3 pi r cubed. We ready? All right, find the volume of a hemisphere with a radius of 6 inches. Well, the volume of a hemisphere is 2/3 pi r cubed. They're telling us the radius is 6, so this is 2/3 pi 6 cubed. So if you make a mistake, the most common mistake I see is that people try to cross simplify the 3 and the 6. Where generally we can do that, but we have an exponent. Remember PEMDAS. Do we have to do exponents first, or can we divide first? Exponents. So you have to actually take care of the exponent before you divide. So we're going to get 6 to the 3rd power. 6 to the 3rd power is not 18. 6 to the 3rd power is 6 times 6 times 6. Anybody get it? 216. So we're going to get volume is 2/3 times 216 times pi. 3 does go into 216. 3 goes into 216 72 times. So the volume is going to be 144 pi units cubed. We ready? All right, volume of the solid. So I should have written that this is scooped out. So what's happened? We have a cylinder, and then what did we do? We scooped out what from it? A hemisphere. All right, volume's very different than surface area. Surface area is everything we can paint. So if we're scooping out of the cylinder in surface area, isn't that more surface to paint? Because now we can paint the inside some of it. But now volume is how much we can store inside of it. So if I'm scooping out from this cylinder, am I adding to the amount of space we can store in there, or taking away from it? Taking away from it. So to find this volume, I'm going to find the volume of the cylinder, then subtract the volume of the hemisphere. You got it. So this is going to be the volume of the cylinder minus the volume of the hemisphere. Volume of a cylinder is area of the base times the height. Volume of the hemisphere is 2/3 pi r cubed. Okay, the base of a cylinder is a circle, so this is pi r squared times h. So pi 4 squared times 12. Can somebody multiply 16 and 12? What do we get? All right, so now we have 2/3 pi 4 cubed because the radius on the bottom is the same as the radius on top. So remember, we need to do exponents before we simplify. So 4 cubed is going to be 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. 3 does not go into 64. So what we're going to do is we're going to create a common denominator. I'm sorry, we're going, sorry, not yet. We're going to multiply across, so we're going to be 128 over 3 pi. Since they're both in terms of pi, now we're going to make a common denominator to be able to subtract them. So can someone do 192 times 3? $576? Thank you. All right, now do 576 minus 128. For what is it? 428? 448. Oh, 448 over 3 pi. 3 does not go into 448, so we are done there. It's units cubed. I didn't write it. That's okay. Are we ready for the next one? All right, so this one's a little bit more involved. Hold on, I'm just seeing how much we have left. All right, we're in good shape. All right, tennis balls are often sold in a can of 3. Assuming that the balls are packed tightly so that they touch the lateral sides and the bases, determine the amount of volume in the can that is not taken up by the tennis balls. The diameter of each tennis ball is 6 centimeters. So we want to find the amount of volume left over in there, so not taken up by the tennis balls. So I want general game plan here. How are we going to find the volume left over? What should we do? Very generalized game plan. Volume of the cylinder, good. And then what? Excellent, minus 3 times the volume of the sphere since there's 3 of them. Excellent, excellent, excellent. All right, volume of a cylinder is area of the base times the height. And then we're going to do 3 times 4/3 pi r cubed. What happens with the 2 3s? They cancel out. Now they're telling us, oh, should I wait for you to catch up? This next part's pretty important in solving this. All right, so they're telling us the diameter of each sphere is 6 centimeters. So you guys are mostly used to seeing the diameter drawn horizontal, right? But isn't the diameter also vertical? So that's where it's going to help us. So if this is 6, and this is 6, and this is 6, height of the whole cylinder? 18. Is that important? Yes. So volume of a cylinder is area of the base, which is pi r squared, times the height of the whole cylinder. Well, if the diameter is 6, what's the radius? 3. So we're pi 3 squared times 18. So 9 times 18 times pi. Somebody multiply 9 times 18 for us. And now we're going to have 4 pi r cubed. So this is going to be 4 pi 6 cubed. Remember, 6 cubed is 6 times 6 times 6. 36 times 6, what does that give us? 216. Times 4? Oh, I'm so sorry. I did the diameter cubed. We're doing the radius cubed. I'm so sorry. Good catch, Holly. Thank you. So we are 4 times, remember 3 cubed is not 27. I'm sorry, it is 27. 3 cubed is not 9. It's 3 times 3, which is 9 times 3, which is 27. You're getting ahead of us. 162 pi minus 108 pi. What does that give us? 54 pi units cubed. All right, so what are your thoughts? This is, again, for number 4, scooped out. What are your thoughts for number 4? You got it. Area. Oh, not area. I knew what you meant. Oh, I went to the wrong page. What happened? There we go. Can I erase what we previously had? I need more space. Thank you. Volume of the big hemisphere minus volume of the small hemisphere. How are we going to figure out the diameter of the inner hemisphere, the small hemisphere? Good. 10 minus 4, which gives us 6, which means the radius is 3 and 3 of the small hemisphere. So the volume of the big hemisphere is 2/3 pi. And now what's the radius of the big hemisphere? That's that. 5. Very good. So pi 5 cubed. So we are 2/3 pi times 125. 3 does not go into 125, so we are going to get 250 over 3 pi minus 2/3 pi 3 cubed. Are we okay? So 2/3 pi 9. So I'm thinking strategically right now. So 3, oh, I wrote 9. I'm just a mess today. 27. So I'm thinking strategically here. 3 goes into 27, right? But I'm not going to actually divide them. Does anybody know why I decided to not divide them? So I have a common denominator, so then I can subtract. So I'm going to leave it like that and just multiply across. 2 times 27 is 54, so we're 54 over 3 pi. And now I can just subtract my numerators. So 250 minus 54, can someone subtract that? 196 over 3 pi units cubed.
On a test, if we cross or if we the 27, we multiply it, would be wrong. Because we get a different answer, right?
You wouldn't get a different answer. You would then have to go back and make common denominators. So you would just add an extra step. All right, ready for number 5? Can I erase from number 4? All right, so we already have a lot going on here. Tell me, what are we finding the volume of? You got it. We're finding the volume of a hemisphere plus the volume of a cylinder plus the volume of a cone. Very good. So we are 2/3 pi r cubed plus area of the base times the height plus 1/3 area of the base times the height. Look at that. So let me show you some strategy here to finding everything we need. I'll give you a second to write down your game plan. Okay, so do we agree that the radius for the hemisphere is 3? This is also a radius. So that means the height of that hemisphere is 3. Well, now, the radius of this base, isn't it the same as the radius of this base? So this cone has a radius of 3, which makes it triple. 3, 4, 5. So then this height is 4 and this height is 3. How are we going to find the height of the cylinder? From what? Good. The total height of this whole pencil thing is 24. Well, I know the height of this cone is 4. The height of this is 3. So I'm going to do 24 minus 4 minus 3, or 24 minus 7. So that means the height of that cylinder is 17. All right, now we're going to plug into our formula. So we're 2/3 pi 3 cubed. So this is going to be 2/3 pi 27, which will give us 9 pi. Not 9 pi, 18 pi. All right, cylinder. What does that big capital letter B represent? Area of the base. What kind of base does the cylinder have? A circle. So this is pi r squared times h. So this is pi 3 squared times the height of the whole cylinder is 17. Can somebody multiply 9 times 17? Say it one more time. 153. All right, and the last one. Volume of a cone is 1/3. That big capital letter B is area of the base. So once again, we're pi 3 squared, pi r squared, because it's a circle, times the height of the whole cone, which is 4. So we're 1/3 times 9 times 4 times pi. 3 goes into 9 3 times, so we're left with 12 pi. Somebody add these all up for me. Say it one more time. 183. We ready? All right, find the volume. Okay. This is volume of this is much better than surface area, I'll tell you that. This was a prism, right? This was a hexagonal prism, and what was scooped out of it? A cylinder. Very good. So this is a volume of a hexagonal prism.
Oh, this goes all the way down?
Mm-hmm. Minus the volume of a cylinder. Yep, there's depth to it. So the volume of any prism is area of the base times the height. The volume of a cylinder is area of the base times the height. But their bases are different. All right, do we agree this hexagon is regular? It's all sides are 6?
Yeah.
All right. Who remembers how to find the value, the area of a hexagon, a regular hexagon?
Half AP?
Good, half AP. So what we need to do is we need to draw in what? The radii to the corners to create triangles. What's the angle for each of these? 60, 60, 60, 60, 60. I left one blank. Why did I leave one blank? Good, so we can draw in our apothem. Now when I draw in that apothem, that top 60 is going to get split in 2. And that 6 on the bottom will get split into 3 and 3. All right, I'll give you a second to catch up. All right, do we all agree this is a 30, 60, 90? So what's the apothem? 3 root 3, very good. So we are half, the apothem is 3 root 3. What's the perimeter? 36. Half of 36 is 18. 18 times 3 root 3 is 54 root 3. So that is the area of the base of the hexagonal prism. What's the total height of this hexagonal prism? 2. Very good. So this is 108 root 3. All right. Volume of a cylinder. Should I give you all a second to catch up? Okay. All right, volume of a cylinder, area of the base times the height. So that's pi r squared times the height. Do we agree they told us the radius is 4? That was labeled for us. So this is pi 4 squared. What's the height of the cylinder? Also 2. You got it. So this is 108 root 3 minus 32 pi. Oh, not equals, minus 32 pi. We can't subtract those. How come I can't subtract those? Because one's a radical, one's a pi. So we leave it just like that. All right, you have finished learning geometry for the year. Congratulations.